Hi guys, welcome to another episode of MrLopezClasses.com. Today we are going to talk about engine analysis. Engine analysis, inboard engines, marine engines, diesel and gasoline. And we are going to analyze the oil sample, the coolant sample, the report of the codes, the OBD2 codes, and we are going to use some tools to analyze the engine using the oil sample, the coolant sample, and the report of the codes. Okay, what are the tools that you need? Number one, the service manual. Use the service manual for that particular engine. Number two, the log book. The log book is the history about the service, the history about the maintenance in the engine. And other important element is talk, listen, the complaint about the customer, about the captain, and analyze the question. Check what happened, visit the boat, check the engine, check the coolant, the oil, check the color of the smoke. Remember that depending on the color, you can take your analysis in one direction or other direction. If it's blue smoke, black smoke, white smoke. This is very, 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 very important. Okay, but today we are going to be concentrated in the oil sample analysis. This is an element that, in my opinion, provide the majority of the information for the engineer, for the inspector about the situation of the engine. Why? Because in the oil sample and also the coolant sample, you will find the concentration of dispersed elements, dispersed metals in that sample. According with the amount of those dispersed metals, dispersed elements, you can predict the situation internally in the engine. And you can do previous actions before you disassembly, before you repair the engine. For that reason, today we are going to analyze what happened when you receive the report of the oil sample analysis and what happened when you receive the report of the coolant sample analysis. Both reports are critical, are very important. Okay, especially the report of oil is important, and we are going to check in this particular case what happened with those elements, with those metals dispersed in the sample. Normally, when you receive the oil sample analysis, you receive a letter with the information about the content, the concentration of each metal in the sample. And in one column, you see the concentration in parts per million of that metal in the sample. In the next column, you see the concentration of that metal in general in this type of engine with that type of oil, the average. And in the last one, normally you see if that metal is, the concentration is too high, is normal, or too low. According with this, it's easy diagnosis and identify where is the problem. Other tool that in some cases help is the compression test. The compression test, in my opinion, help a lot. If the engine is gasoline, it's simple. Take the compression test. You remove the spark plug, you introduce the tester, and you crank the engine. It's easy. In diesel, you need special tools to remove the injector. And in the hole where the injector is located, you install the compression tester. But in some cases, you don't have that tool. In that case, I recommend don't touch the engine. Don't try to remove the injectors. If you don't have experience removing those injectors, and also if you don't have the tools, don't try to do that. Okay, we are going to analyze what happened with those dispersant elements in the sample. Okay, number one, we are going to check, for example, chromium. What happened with chromium? In what type of elements in what type of elements, components of the engine you find chromium. Okay, in the crankshaft, in the camshaft, in the pistons, in the piston rings, and also in the valves. The most important is in any of those elements, which one is the element with higher concentration of that element, of that metal. In that particular case, is on the valves. 12% is in chromium. It's a lot of chromium on the valves. Other element with high concentration is on the camshaft. Okay, we are going to check. In the first 2 or 3 elements, we are going to check the analysis of each one. It's basically the same for the other one. Okay, what happens if I have high concentration of chromium in the valves? We are going to check what happened in the valves. Of course, if I have wear metal on the valves, probably the oil penetrates into the combustion chamber. You remember that slide? Because there are too much play in between the valve and the valve guide. Okay, if this is the case, you have blue smoke, of course. And or if the valve don't close properly, you have low compression. Or if the valve is moving because too much play is producing a knock, you have a knock sensor activated. Those are the symptoms. Okay, great. What happens if the concentration is on the crankshaft? On the crankshaft, probably you have the crankshaft position sensor activated. And those are the codes related with the crankshaft position sensor, P0300 until P0330A. Different possibilities for a crankshaft position sensor. Okay, normally is misfiring, acceleration is not clear, backfiring, the engine no start easily or no start, and vibrations, misfiring. Okay, this is if it's on the crankshaft. What happens if the situation is on the camshaft? On the camshaft. Okay, on the camshaft is a little different because if I have wear the camshaft, what happens with the loads on the camshaft? They are rounded, and probably the valves not open and not close completely. And probably you don't have the amount of air entering in the combustion chamber. And probably not all the exhaust gases are out because the camshaft is where the loads are rounded, not pinned. In that particular case, you have misfiring, you have a detonation, you have explosions. It's like if the timing is affected. And also, you have a hard start, loss of power, and probably noise. No? Those are the codes, P0300, 301, 340, and 344. Those are the most common codes related with problems on the camshaft. Great, no? What happens if the problem is on the piston rings? What happens if the problem is on the piston rings? Okay, probably the oil penetrates the combustion chamber, blue smoke. If the piston rings are wear, probably low compression, loss of power. Let me check. Exactly, loss of power, low compression, blue smoke. Those are the typical symptoms when I have a problem with the piston rings. This is when I have excessive amount of chromium in the sample. Okay, great. Let me analyze another metal, magnesium. Magnesium. Where I have magnesium. In what type of components? I found that high quantity of magnesium. Okay, once again, in the camshaft, in the cylinder liners, in the pistons, in the aluminum pistons, in the heat exchangers, it's a copper nickel alloy, in the piston rings, and in the valves. And once again, the analysis is pretty similar. We checked in the previous the analysis of the valves, the camshaft. What happens if the problem is on the cylinder liners, the liners? Okay. Once again, loss of power, low compression because the metal is wear, blue smoke. Okay, great. What happens if the problem is on the heat exchanger? On the heat exchanger. Okay, the temperature increase. Probably I have lack of raw water. The circulation of raw water in the exhaust pipe is less. Loss of power, detonation, misfiring. Yes, those are the elements, the situation if I have excessive amount of magnesium. Okay, we are going to analyze what happened with carbon. In what elements I have high concentration of carbon. Once again, crankshaft, camshaft, cylinder liners, piston rings, and valves. And we know the situation in each of those. And now we are going to analyze what happened with silica. Where I found that high content of silica? On the crankshaft, camshaft, cylinder liners, valves, piston rings, plain bearings, practically the same elements. And the analysis is exactly the same. What happens if I have high concentration of tin? Okay, where I found the tin? In plain bearings, there are two types of plain bearings, you remember? Plain bearings with a soft metal or babbitt on the crankshaft in both journals. You remember those bearings? Yes, that white metal is babbitt. It's an alloy with a high content of a tin. Alright. In the plain bearings babbitt, 80% of that metal is tin. 80% is practically pure tin. If I have excessive amount of tin in the oil sample, it's basically because the plain bearings are wear. What is the symptom number one? Yes, the oil pressure goes down. If you check the oil pressure gauge, the pressure is down. And probably the problem is that the engine start, run a couple of minutes and shut down for low oil pressure. Yes, because the bearings are wear. And also probably you have activated the knock sensor because it's too much play. Yeah, that sensor is activated. Knock sensor activated, low oil pressure. And let me check what happened in that case. Yes, low oil pressure, knock sensor activated. Those are the codes related with when you have problem with the bearings. Great. What happened if you have problem with the copper bearings? Where you found that copper bearings? You remember? Plain copper bearings. On the turbo. You remember those bearings on the turbo? You remember the speed of those bearings when the turbo is spinning? Is more than 150,000 RPMs. It's a lot. Yes, if those bearings are wear, you have lateral play on the turbo. And that's not good. That's not good. What is the symptom? Again, low oil pressure. Low oil pressure. And of course, you find a lot of tin in the sample. Look, in those copper bearings, the concentration of tin is 15%. It's a lot. Why? Because tin and lead, they are good lubricants. Yes, if you check both analysis, the analysis of tin and the analysis of lead is pretty similar. Problems in the bearings, in the babbitt, plain bearings of the crankshaft, and the bearings, copper bearings, on the turbo and the small end rod of the connecting rods are in copper. And the analysis is the same. Yeah, it's practically the same. Look at the amount of lead in plain bearings with babbitt, with the white metal, 8%, a lot of lead. And what about in the copper bearings? 10%. Oh, okay, it's a high concentration of lead. What is the function of the lead in those alloys? You remember that the lead is located in the group number 4 of the periodic table, is heavy, and the melting point is too low. It's in the bottom of the group number 4. The melting point is too low. Yes, when the temperature of the oil increase, when the engine is at operational temperature, that metal tries to become liquid and help improve the lubrication. Once again, when the temperature decrease, will be solid. For that reason, those plain bearings, they have a high content of lead. Lead is the lubricant is because the melting point is too low. Okay, great. And the analysis is pretty similar with lead. Okay, we can check other type of elements. For example, a nickel. Nickel is excellent. Where do you think that we can find nickel? Yes, in the heat exchangers. All the coolers in the engine, they have high concentration of nickel. Can you refresh me the coolers that we have in a typical inboard, for example, diesel engine? We have the heat exchanger or a cooler for coolant. That's the number one. Other cooler for engine oil, correct? Other cooler for transmission oil. Other cooler for fuel. Other cooler for hydraulic oil, power steering fluid. Other cooler for air. What is the name of the air cooler? Intercooler, correct? Yeah, six air coolers. All of them use the path of the raw water, to cool different fluids. Yes, those coolers, those heat exchangers, internally they are fabricated in a special alloy, copper nickel. The most famous copper nickel alloys are copper nickel 7010 and copper nickel 9010. Okay, we are going to check what happens if I have excessive amount of nickel. Where I found that nickel? Okay, nickel once again in the crankshaft, in the camshaft, in the aluminum, in the pistons, in the heat exchangers, and in the valves. Once again, the valves 1.5% is nickel. In the crankshaft, 185% is nickel, and of course more than 10% in the heat exchangers. In the pistons, aluminum pistons, 1%, around 1% is in nickel. Those numbers are average. It's not exactly that amount, but it's pretty close. It's high concentration, no? And you know the analysis, because the analysis is the same. You remember we analyzed what happened in the crankshaft, what happened in the valves, what happened in this particular case in the heat exchangers. In the heat exchanger, of course, the temperature of the engine is high. Probably I have a lack of raw water, loss of power, problems related with the temperature. And of course, if the heat exchanger is cracked, for example, the heat exchanger for coolant, if it's cracked, the salt water is mixed with the coolant. If the oil cooler is cracked, probably if I check the oil is milky oil. Or if what happens if the intercooler internally is cracked? If it's cracked, the intercooler, what happened? The air enter with salt water in the combustion chamber. Catastrophic. The engine says immediately. Why? Because the thermal expansion of the aluminum piston is twice in comparison with the thermal expansion of the cylinder liners in steel, and lock the engine. This is a topic for other episodes. You can check all of those episodes in my course of marine diesel engines, and also in my course of marine gasoline engines, and also in the books. What books? The marine diesel engines and the marine gasoline engines. You enjoy the video? I appreciate with the thanks, with the button of thanks, or with a like. This is the only way to continue with this project. Okay guys, don't forget the analysis of the smoke. If the smoke is black, if the smoke is white, if the smoke is blue, if the smoke is white, it's probably humidity entering in the combustion chamber. Remember that you have two types of humidity. Humidity coming from coolant entering in the combustion chamber, and humidity coming from salt water. That's not good in general. If the amount of salt water is a lot, immediately the piston expands. If it's a small amount, probably the engine continues running, but suddenly stop. Salt water is not good in the combustion chamber. Okay, if the problem is salt water, you need to analyze the path of salt water. If the problem is coolant, you need to analyze the coolant side. This is for white smoke. For a blue smoke is oil entering in the combustion chamber. You remember in this analysis, normally it's because it's a problem on the valves. On the valves, the valves are wear, too much play into the valves and the valve guide, the oil penetrates the combustion chamber, and you know the consequence. Some people say piston rings, but normally if you have wear piston rings, you have low compression. Remember that in the piston ring, the bottom one is the oil controller ring. It's used to return the excess of oil into the oil pan. For that reason, especially in diesel engine, you have 2 or 3 compression rings. It's difficult that the oil pass to the combustion chamber through the piston rings. Normally it's through the valves. Okay, but this is the analysis, my friends. I hope you enjoyed this video, and also if you complement this video with other videos where I explain how to read, how to analyze the coolant sample analysis, and other videos related with the codes, OBD2 codes, those videos, you will be a successful technician, marine technician. Don't forget, try to fill every day in your boat the logbook. And the logbook is the history about the service. When you sell the boat or when you buy a boat, it's important ask about the logbook in order to check what type of oil is used in those engines, in those generators. What is the service in the fuel injection pump? What about the service in the injectors? What about the service in the filters, fuel filter, water separator filters, secondary filters, air filters, and with those parameters, it's easy the procedure to solve problems. If you enjoy this episode, make a click in the like or thanks. I appreciate your collaboration, your support.